So this is Calc 1. We're going to be talking about maxima and minima for functions. So basically, there are two important theorems with this section, and that is, finding the absolute maximum and the absolute minimum, which basically states if you have, say, some function f of x equals, some arbitrary function. I don't know. We could make something up like x squared. And, we want to find the absolute maximum minimum values of this function on a particular interval where x is, say, is on like -1 to like 3. Okay, you find the absolute maximum, absolute minimum. Basically, that means you find all the points that you can in that function and see where the maximum and minimum values are. So there is a little bit more to it, though. In particular, suppose, for example, I have a function, we'll call it g of x, where g of x is x to the 4th minus 2x cubed. And it's on the interval -2 to 2. Well, first all, you have to find the critical points. So the critical points, first off, critical points are where, they tell you other possible values where you could have the absolute maximum or minimum, or maxima or minima, meaning if you have more than one, plural. So the way you find those critical points is you take the first derivative and set it equal to 0. So I have g of x equals x to the 4th minus 2x cubed. So the first derivative, g prime of x, well, it's just a power rule, 4x to the 3rd minus 6x squared. Set it equal to 0. Make that 3 a little more noticeable. Well, this comes back to algebra. I factor here. I can factor out an x squared and a 2. So I take out 2x squared. That's going to give me 2x minus 3 equals 0. So now if I set both of these equal to 0, well, we already know using algebra, this will give us 0. With this equation, if I add 3 to both sides and divide by 2, x is 3/2. So those are the two critical points. I'm going to abbreviate them C, P. So the first things first, do they lie in the interval? 0 is on the interval because it's between -2 and 2. And 3/2, which is 1.5, well, that's also in the interval. So that means we have to test the two critical points and the two endpoints. So it doesn't matter which order you do it in. I guess, we'll do the endpoints. Well, let's do the critical points first. So g of 0, I plug in 0 for x. Well, that gives me 0. That's a simple calculation. G of 3/2. Well, this one's a little annoying. So I want to take 3/2 to the 4th. Oops. Yeah, 3/2 to the 4th minus 2 times 3/2 to the 3rd. So I keep doing the calculation. That's going to give me 81/16 minus 27/8 times -2 is -54/8. And then if I make them both 16, that's going to give me 81 minus 108, because I just doubled 8 here and gives me 16, double -54 gives me -108. So then 81 minus -108 is -27/16. So therefore, we have g of 0 equals 0. G of 3/2 is -27/16. So we tested 2 critical points, 0 and 3/2, but now we got to test the 2 endpoints. So we do g of -2. Plug that in, you get -2 to the 4th minus 2 times -2 to the 3rd, which is going to equal 16. And then -2 times -8, that's going to be 16 again, 32. So g of -2 equals 32. And then now we're going to have to do the other endpoint, g of 2. So g of 2, plug in 2 for every x, that's 2 to the 4th power, minus 2 times 2 to the 3rd. So it's going to be 16. You get -2, and then 2 to the 3rd is 8. So -16 equals 0. So g of 2 equals 0. Well, now we did the hard part. So now we just got to find the absolute maximum, absolute minimum. Well, let's look at all the values. You have 0 here, 32, -27, or 16. This is the lowest because this one's negative, all the other ones are not. So this would be the absolute minimum. And what's the maximum? Well, that's absolute min. This is 0. Well, it has to be 32. So this would be the absolute maximum. So therefore, the absolute minimum for this function on the interval -2 to 2 would be -27 over 16, which occurs at when x equals 3/2. And the absolute maximum would be 32, where x equals -2. So that's basically the kind of problems you come across in this section. It does lead into more important topics in the course. So now let's look at something else. I'm just going to clear the board. So now suppose I have the function f of x equals sine of 3x, where x is on the interval, -π/4 to π/3. Well, just like the last one, I got to find the first derivative set equal to 0 because that's how we find our critical points. So the derivative of sine 3x is cosine 3x times 3, set equal to 0. So I divide both sides by 3. Cosine of 3x equals 0. Well, now I have to find where does cosine equal 0 on the unit circle. Well, if I look at my unit circle, I draw it really quick. Cosine is 0 here and here. So at π/2 and 3π/2. So it'd be π/2 plus 2πn, where n is an integer. The other one would be, okay, 3π/2. So I'm just going to write this here. Or again, n is an integer. Now for this one, I could pick different, well, actually, we're not done yet, my bad. So we wanted to solve for x, multiply by 1/3 for everything. So then x is going to equal π/6 plus 2/3 πn. This one is going to be, x is going to equal π/2 plus 2/3 πn. So again, this goes back to trigonometry. You pick integer values that satisfy it. You pick values for n which are integers, such that you get your x values that satisfy the equation. But also keep in mind, for this particular case, it has to lie in this interval. So when you solve these, you wind up getting a couple critical points. You get x equals π/6, -π/6, and negative pi over 2. So now you got to test all these into the original function. So first off, pi over 6, that lies in the interval. That's good. Negative pi over 6, that lies in the interval. Negative pi over 2 does not because of the negative pi over 4. So negative pi over 2 will lie on the outside to the left of negative pi over 4. So that one doesn't count. So because of that, it makes it a little bit easier. We only have to do 4 calculations. So let's do the calculations for the critical points. So f of pi over 6, you plugged it in for sine, 3 times pi over 6. That is just going to give you sine of pi over 2, which is equal to 1. So f of pi over 6 equals 1. And then we do for negative pi over 6, which is just going to be the same thing, except now it's just going to be negative pi over 2. And sine of negative pi over 2 is going this way, which would be negative 1. And now we want to do f of negative pi over 4. You plug that in here, you get sine of negative 3 pi over 4. And sine of negative 3 pi over 4. I'm going back to the unit circle. Well, negative 3 pi over 4 would be negative pi. It's going to be in here because this is negative pi over 2. If we go this way, negative pi over 2, this is negative pi. So negative 3/4 pi is going to lie in this quadrant. And all students take calculus, so it's going to be negative. And the reference angle is going to be pi over 4. So that means we know that reference angle tells us that sine of pi over 4 is radical 2 over 2. And since we're in the third quadrant, it's negative. And then the last point is finding pi over 3. So f of pi over 3, we plug that into here. 3 times pi over 3. That gives me sine of pi. Sine of pi is just 0. So we have to look at, well, where's it doesn't matter which one you look at first, maximum. So the absolute maximum, we have 1, 0, negative 1, negative pi over 2. Well, it has to be 1. So this would be the absolute max, which is 1, and occurs at pi over 6. And then we have to find the absolute minimum. Well, we have 0, negative 1, negative pi over 2. So it has to be one of the negative ones because 0 is greater than any negative number. And well, really, which one is more negative? Well, negative root 2 over 2, that's going to be less negative than this. So therefore, the absolute minimum is negative 1, which occurs at where x is negative pi over 6. And that's pretty much it. That's basically this whole section. So I hope this video helps, and I'll see you guys next time. Bye-bye.